Here's a substitution problem in the form of a definite integral from the OpenStax Calc 2 textbook, Chapter 1, Problem 309. We're looking at the antiderivative of a quotient, and if you've practiced with these, chances are we're going to say, hey, let the denominator be u, and then the numerator will be related to du. And I have the easy multiplication hidden by Hawkeye here. I've multiplied out the denominator, and so there you can see pretty well that if the denominator is going to be what we substitute for, so if we say, well, let me simplify this one more step perhaps, and I'm going to separate the 1 plus the 3/4. There we go, 3/4. And let's order those terms in the denominator. So what I've done is I've sort of grouped what's going to remain versus what's going to be part of du. And you can see, the derivative of t squared is 2t, and the derivative of t is 1. There's a minus sign discrepancy, but no big deal. So let's go ahead and say that this whole denominator is what we're going to repackage as u. Remember, make it easy. With all of that, let's take the derivative of both sides of this substitution expression. That's going to mean that -1 plus 2t dt will be equal to du. Now this is the opposite of that. So this expression is ready to be 1 over u. This we still have to deal with a little bit. The expression we have here is not du, it's actually negative du. So chosen expression for u, derivative, compare to what we're going to end up replacing. See, we've got a negative sign discrepancy, and so multiply both sides of this by -1, and now we have the perfect match. Now the other thing we have to do is change the limits. So we're going to take these numbers with this substitution expression, and we're going to go back to the 0 and the 1 and say, hey, those are values of t. What are the corresponding values of u? Well, when t equals 0, this substitution expression tells us that u is 3/4, plugging in 0 for t. And when t is 1, u is going to be 3/4 minus 1 plus 1. What do you know? We end up getting the same value for u from both of the endpoints. Well, it is what it is. Let's complete the substitution just for practice. We've changed limits. The quotient, or the rational function, is just 1 over u with our substitution. Over here we get negative du. And we could tidy this up a little bit, but looking at that, this is going to be 0. A definite integral between identical endpoints is 0. And here is some graphical evidence that a value of 0 for this result is not terribly wacky. Courtesy of Maple, here is a plot of the function we just integrated, 1 minus 2t over 1 plus the quantity t minus 1/2 squared. And you can see that it's symmetric above and below the x-axis. It crosses the x-axis at t equals 1/2 because that's where the root is. And so you can see that the net area under this curve turning out to be 0 between t equals 0 and t equals 1 isn't really unexpected.